Hey there, 6th grade. In this video, we're going to talk about properties of polygons. So a polygon is a closed figure made up of 3 or more line segments. And a couple of characteristics of polygons are, number one, these line segments do not cross. And also the line segments are indeed line segments. That means a polygon cannot contain any curves. Okay, so we're going to look down below at some examples of polygons versus non-polygons. Okay, so first of all, I said polygons are closed figures. So that means that all the line segments must be connected. You cannot have any gaps, okay, in your shape. Otherwise, you don't have a polygon. So, for instance, this almost square over here is not a polygon because of this gap here between the line segments. A polygon cannot have any line segments that cross, so this crossing right here in these line segments makes this figure not a polygon, and there can be no curves in polygons. So a circle is not a polygon, and this little crescent moon shape is not a polygon. Okay, so polygons, their line segments are called sides. The sides meet only at their endpoints, and then the points of intersection on the sides are called vertices. Okay, so these points here where one line segment intersects with another, these would be called the vertices of a polygon. Down below, we'll talk about how to classify polygons. We classify polygons based on the number of sides they have. Okay, so we've already talked about, you'll notice in this table we're missing polygons that are 3 and 4-sided. Okay, well, we've already talked about those in the previous lessons. A 3-sided polygon is going to be a triangle, and a 4-sided polygon is what we did in the last lesson. That's a quadrilateral. Okay, moving forward, the number of sides 5 and up, we're going to use this terminology to classify polygons. So a 5-sided polygon is what is called a pentagon. Okay, and if you've ever heard of the Pentagon located in Washington, D.C., it's got this shape actually from above, a 5-sided shape. So that's how you could remember what a pentagon means. A 6-sided polygon is what's called a hexagon. The prefix hexa means 6. A 7-sided polygon is what's called a heptagon, hepta with a PT. An 8-sided polygon, a lot of people know this shape. It doesn't have to be the shape necessarily, but a stop sign is a good example of an 8-sided polygon. That's in the form of an octagon. A 9-sided polygon is what's called a nonagon, and a 10-sided polygon is what's called a decagon. You could have polygons that are more than 10 sides, and typically, if we have a polygon that's more than 10 sides, we'll refer to it just as a 11-sided or a 12-sided polygon. And typically I won't require you to have any more vocabulary besides 5 through 10 on here. Okay, so on the back side of your notes, in the first couple of examples here, we're just going to determine whether or not each of these figures is a polygon. If it is, we're going to classify it using one of these terms here, and if it's not, we'll explain why. So number one, think for a moment to yourself whether or not this figure is a polygon based on what we talked about on the front side. Okay, based on what we talked about, this is not a polygon. And the reason it's not is because it has curved sides, okay, or it has curves. This is an oval shape, and polygons cannot have curves, so that's why this one is not a polygon. Number two, think about whether or not this is a polygon. Number two is a polygon. It's a closed figure. It's made up of only line segments, okay, and those line segments do not cross, so that's what makes this a polygon. Now classify it. So how many sides does it have? Well, we have 1, 2, 3, 4, 5, 6, and 7 sides. So remember, a 7-sided figure is what we call a heptagon. Okay, so number 2 is a polygon, and specifically it's a heptagon. Okay, next we'll talk about the angles of a polygon. So an interior angle is an angle that lies inside a polygon. And we're going to find that the sum of the interior angles of a polygon can be found using the following expression. So if you take the number of sides of the polygon, and then you subtract 2 from that number. So the number of sides minus 2, and then you take that quantity times the number 180. That will give you the total number of degrees inside any polygon. Okay, the number of sides minus 2 times 180. And you can actually see that that's true based on what we know about triangles and what we know about quadrilaterals. Okay, think about for a moment how many sides a triangle has. A triangle has how many sides? It has 3. So if you take 3 minus 2 times 180, well, what does that give us? That gives us 3 minus 2 is 1 times 180. That gives us 180 total degrees, which we know is how many degrees is in a triangle. We could do the same thing for a quadrilateral. Okay, this is what we talked about in the last lesson. So a quadrilateral has 4 sides. So if we take 4 sides and subtract 2 times 180, well, 4 minus 2 is 2, times 180 gives us 360. And we know from our last lesson a quadrilateral has a total of 360 degrees in all of its angles. Okay, so this is the expression you can use to find the total number of degrees for any polygon. The number of sides minus 2 times 180. So if I have a pentagon, for instance, well, a pentagon has 5 sides, so this would be 5 minus 2, and then that quantity times 180. 5 minus 2 is 3, so this is 3 times 180, and that's going to give us 540. So in any pentagon, the total of all of the angles added together will be 540 degrees. For an 18-sided polygon, okay, we really don't have a name for that besides calling it an 18-sided polygon. We would take the number of sides, again 18, and subtract 2 times 180. 18 minus 2 is 16. And so then 180 times 16 is going to give us the sum of all of the angles. So if we do that, we should get 2,280 degrees. Okay, that is the sum of all of the interior angles in an 18-sided polygon. Okay, lastly in this video I want to talk about what are called regular polygons. So a regular polygon is one that has both congruent sides and congruent angles. Okay, congruent sides and congruent angles. A square would be a good example of a regular polygon because remember, a square, all of the sides are congruent and all of the angles are congruent. All the angles are 90 degrees. Okay, so a regular polygon has to have these two characteristics. And anytime we have regular polygons, we're able to find the individual angle measures. Okay, so the measure of each individual interior angle inside a regular polygon can be found by dividing the sum of the interior angles by the number of sides the polygon has. Okay, so if you take the sum of all the interior angles and divide it by the number of sides the polygon has, that will give you the measure of one individual angle. So we'll do that here in example 5. Example 5 is asking what is the measure of each angle of a regular hexagon. Okay, so the first thing we need to do is we need to figure out, okay, how many degrees total does a regular hexagon have? So we'll do that using our expression up here. So let's think about how many sides a hexagon has. A hexagon has 6 sides. So that's going to be 6 minus 2, the quantity, times 180. 6 minus 2 is 4. So the total number of degrees inside a hexagon is going to be 4 times 180. And that's going to be 720 degrees. Okay, so that is the total right there. So now, to find the measure of just one of those angles, I want to take that total, 720, and divide it by the number of sides. Okay, a hexagon has, again, we said 6 sides. So that means we'll be doing 720 divided by 6. Well, 6 will go into 720 120 times. Okay, so that means that each angle inside a regular hexagon is going to measure 120 degrees. All right, if you have any questions over this video, be sure to jot those down and ask those the next time I see you in class. Until then, have a nice day. You're all wonderful people. Take care.